Southington, a suburb of Hartford, Connecticut, was home to the former Solvents Recovery Service of New England, or SRSNE. In the mid-20th century, it was common for companies throughout the New England area to send solvents used in manufacturing to SRSNE to recycle. This practice was used to avoid dumping waste solvents in landfills. Distilling and reusing the solvents was an early recycling approach common for manufacturing operations at the time. In the course of operations, distillation of these solvents generated unusable solvent sludge that was placed in unlined lagoons on the SRSNE property. The ongoing releases represented significant groundwater impacts. The site was added to the EPA's Superfund list. SRSNE shut down operations in 1991, and the EPA and state reached a settlement with potential responsible parties. Over the years, the site has benefited from significant remediation efforts.
In 1984 is when I first got involved at the site. I worked for BBL in Syracuse at the time, and our job was to design the hydraulic containment system. And that hydraulic containment system ended up consisting of a sheet pile wall to contain a zone 500 feet wide in the direction perpendicular to the groundwater flow direction. And that wall went all the way down to the bedrock.
Pumping wells collected groundwater with the highest concentrations contained by the sheet pile wall. After thermal source zone remediation, the team developed a method to perforate the sheet piling, create a permeable reactive barrier, and stop pumping.
At SRS, I've been working on the site since 1995, so I've gotten to see the site from investigation through removal actions and now through the remedy and into operations and maintenance. And then perforinateds came to be a thing, and the state said, well, can you go sample for those? And we did.
PFAS, an acronym for a family of chemicals known as PER, and polyfluoroalkyl substances, are man-made compounds with a widespread commercial use in surface coatings, like non-stick surface treatments used in water-repellent clothing, carpeting, and food packaging. EPA's current recommended drinking water advisory levels for PFAS and PFOA are not to exceed 70 parts per trillion, alone or in combination. To put that in perspective, it can be compared to 3 drops in an Olympic-sized swimming pool. Samples collected by GEI Consultants, the environmental firm tasked with data collection, indicated that PFOA and PFAS concentrations in groundwater samples from the site exceeded the EPA's drinking water advisory levels.
It sort of put us in a position now where if we're going to allow groundwater to flow down gradient from this area we just cleaned up thermally, how are we going to prevent the PFAS from migrating downstream? And I think Bruce attended a conference and he saw this plume stop, be advertised and said, hey, that's something that might work great for our site.
And right about the time we got the results and said, now we need something to treat it. I just come back from the Battelle conference and had seen a number of Regenesis presentations and said, the liquid activated carbon may actually be a good result for us or a good way to treat this. And it did.
Plume stop, a patented form of colloidal activated carbon, flows into contaminated aquifers, coating the aquifer matrix with a micron-scale layer of activated carbon, effectively converting the contaminated aquifer into a large purifying filter, similar to a Brita filter.
It's not like a filter that you might have on the nozzle of your sink where after some period of time when it's used up, you unscrew it, throw it away, and you put a new one in. It's in the ground. It's there essentially forever. So we had to be conservative in the design to make sure we were applying enough of this product that it's going to last for years and years and years. And the expectation is here a minimum of 50 years.
And so the system forces all the flow to go through 3 little points. And ultimately, we concluded that if we were to inject treatment reagents into that trench system, we would force all that groundwater to go directly through treatment media. And that's a powerful opportunity.
Everything comes down to a cost-benefit test. And at this site, it's many years of cost-benefit. So it's not just a 1 year we could get to shut it down. I'm looking at if I can save 30 years of running a particular system, it'll very quickly pay for itself. At this site, if you extend that out, it's millions of dollars in savings, present worth to the clients. We've finished all the required remedial work, and we're now into O&M. It's been actually a privilege to work on this with Regenesis. Our clients, the consultants, the contractors, the regulators, it actually really has been a team effort, and I think that's why it's been a success.